Hello and welcome to helpyourmath.com. In this video, we're going to look at examples of simplifying rational expressions. And just a reminder, what we do when we simplify rational expressions is we look for common factors between the numerator and denominator. Factors are things that are being multiplied. So if we have a times b in the numerator and a times c in the denominator, we can divide out that factor of a, leaving us with b over c. We don't get to do that if something's being added, right? We cannot say that a plus b over a plus c is equal to b over c. That's not how this works. This is a big fat no. Don't do that. We look for factors. Looking for factors may require us to have to, well, factor. So be aware, we're going to be factoring. Let's get started. We want to simplify the rational expression. We have k squared plus 8k minus 9 over k squared minus 5k plus 4. One of the most common mistakes that I see students make is they cancel out the k squareds because they're like, look, there they are, yay! But k squared is not a factor. It's being added to something. Factors, the only thing that they're doing is being multiplied to other factors. So we can't simplify those k squareds, resist the temptation. What we want to do is we want to see, can we factor the numerator? So the numerator, we have k squared plus 8k minus 9. This is a trinomial, right? I see three terms. So we want to see target product, target sum. The leading coefficient's 1, so if we find our winning combination, we can plug those winning combinations right into the factors. Target product here is going to be 1 times negative 9 or negative 9, and the target sum is going to be positive 8. So we're looking for two numbers that multiply to negative 9 and add up to positive 8. Can you think of two numbers that do that? How about positive 9 and negative 1, right? Those multiply to negative 9, they add up to positive 8. So that means that the numerator will factor into k plus 9 times k minus 1. Okay, so we're going to rewrite our numerator. I'm going to put it over here. K plus 9 times k minus 1. So we have two factors in the numerator. Two factors in the numerator. I can either simplify one of those with something in the denominator, or I can't simplify at all. In the denominator, we're talking about k squared minus 5k plus 4. We want to try to factor this. The target product will be a times c, which would be positive 4. And the target sum will be that middle coefficient b, negative 5. Can you think of two numbers that multiply to positive 4 and add up to negative 5? Well, how about negative 1 and negative 4? Negative times negative gives us that positive product. Negative plus negative gives us that negative sum. And we can plug these right in, so this will become k minus 1 over k times k minus 4. Now that it's factored, we can look for common factors. Do you see a common factor between the numerator and denominator? How about that factor of k minus 1? So we can cancel out the k minus 1s, leaving us with our simplified expression k plus 9 over k minus 4. And there it is. So that would be the simplified version of k squared plus 8k minus 9 all over k squared minus 5k plus 4. In our next example, we have a to the 4th minus 16 over a minus 2. The good news is that the denominator can't be factored. It's as factored as it gets. So that indicates to us that there's one factor in the denominator. Either we cancel out a minus 2 or we can't do anything at all. Looking at the numerator, so the numerator we have two terms, a to the 4th minus 16. I don't see a greatest common factor. The next thing, I'll go through my checklist of what should I look for with two terms. How about difference of squares, right? I see the subtraction. Is a to the 4th a perfect square? It is. It's a squared squared. And 16 is a perfect square because it's 4 squared. So we can factor the numerator into a difference of squares. It's going to be root minus root times root plus root. So now we have two factors in our numerator, but can we continue factoring either one of these? If you look at this first one, be aware, because we still have a difference of squares, right? We have the subtraction. A squared is the perfect square of a, and 4 is the square of 2. So we can yet again factor one of the factors of the numerator. And now it's going to become a root minus root times root plus root. This is unfactorable, so we'll just leave it a squared plus 4. So now when I rewrite the expression, the numerator I'm going to say is a minus 2 times a plus 2 times a squared plus 4, all divided by a minus 2. So is there a factor of a minus 2 in the numerator? Yes, there is. We can cancel it out with that 1 in the denominator. Having just a denominator of 1, we can get rid of the denominator altogether, leaving us with a plus 2 times a squared plus 4 as our final answer. Okay, let's see what we have going on here. I encourage you pause the video, see how you can handle this one. Okay, the first thing I notice in the numerator is that the term with the higher exponent is second and negative. That's pretty uncommon, so I'm going to actually flip it around. So I'm going to write it as negative x cubed plus 9x. And then what I'm going to do is, oh look, it's 2 terms and we do have a GCF, right? Both terms have a factor of x. I don't like that first term being negative, so I'm actually going to factor out a negative as well. So I'm going to factor out negative x. So I'm dividing both of these terms by negative x. That's going to leave me with the first term being x squared and the second term minus 9, right? Because it's going to change the sign since I factored out the negative. Now that I factored out the greatest common factor, is this still factorable? Yeah, it is. It's a difference of squares, right? X squared is a perfect square, 9 is a perfect square. So the numerator is going to factor into negative x, and then it's going to be root minus root times root plus root. All right, so we have our numerator. I'm going to bring it down here. We have negative x times x minus 3 times x plus 3. In the denominator, let's see what we have here. So the denominator, we have a GCF of 1, and we have nothing special about this. This is just your run-of-the-mill trinomial. So we need to do target product, target sum, and we need to expand the middle. The target product for this one, the target product is going to be 2 times negative 9, which is negative 18, and the target sum is negative 3. So we're looking for 2 numbers that multiply to negative 18 and add up to negative 3. Can you think of 2 numbers that do that? How about negative 6 and positive 3? So we're going to use our winning combination, and we're going to use these as coefficients of the middle term. It's called expanding the middle. We're going to replace negative 3x with negative 6x and 3x. So it's going to be 2x squared minus 6x plus 3x minus 9. Now that we have 4 terms, we can factor by grouping. So I'm going to group my first 2 terms, group my second 2 terms. I'm going to keep this off to the side here because this is just the rest of my work, and pull out the GCF from each grouping. So 2x squared and 6x have a common factor of 2x. That leaves behind x minus 3. The second grouping, I have a GCF of 3. When I divide 3 into both of these, I'm left with x minus 3. And now I have 2 terms. Do those 2 terms have a greatest common factor? Yes, they both have this x minus 3. So I end up with x minus 3. And what's left from the first term? 2x. What's left from the second term? Plus 3. So that's my denominator. I'm going to write that as x minus 3 times 2x plus 3. And we did all that work. Did it pay off? Yes, we have a common factor. X minus 3's will cancel, leaving us with negative x times x plus 3 over 2x plus 3. And if you want to expand or distribute the negative x, you can do that if you want. I just say the less work you do, the better off you are. So I would leave it like this. And our last example, you want to try this one? Hit pause. Oh boy, this one looks meaty. Okay, so we have 8x cubed plus 20x squared minus 12x. What I'm noticing in the numerator is that we do have a GCF. The exponents go in order, so I like that. So 8, 20, and 12 all have a factor of 4 in common. X cubed, x squared, and x all have a factor of x in common. So let's factor out 4x. That's going to leave me with 2x squared plus 5x minus 3. And now we want to see if this is factorable, this trinomial. So the target product of the trinomial is going to be 2 times negative 3, which is negative 6. And the target sum will be that middle coefficient 5. So we're looking for 2 numbers that multiply to negative 6 and add up to 5. You have to be really careful with target products of 6 and 5 because there's 2 combinations that work. You have to pay close attention to the signs here. All right, we're looking for negative 6. So we need one of these things to be negative and one to be positive. I'm thinking we're looking at negative 1 and positive 6, right? 2 and 3 also would work, but one of them has to be negative, but we need it to add up to 5, so it's not going to work with 2 and 3. It has to be negative 1 and positive 6. We're going to use these to replace that middle coefficient 5x. so that we can expand it. So this is going to give us, I'm going to write it over here, so I'm utilizing as much of the space as I can. 4x times 2x squared minus 1x plus 6x minus 3. This is going to allow me to group and group. And this gives me, we're going to factor out a GCF from 2x squared and 1x, that would be x, leaving behind 2x minus 1. In the second grouping, we have 6 and 3. I'm going to factor out a 3, leaving behind 2x minus 1. Now, these two terms inside the brackets have a common factor of 2x minus 1, so we're going to factor that out. We get 4x times 2x minus 1 times x plus 3. Whew, that was a lot of work. Okay, looks like the denominator is going to be equally as bad. So we're going to cut off the numerator. I might change the color just so that we can see the denominator clearly. I'm going to remember that this is where my numerator is. Okay, for the denominator, we have, whoops, I want to turn it around. So I'm going to write it as negative 4x to the fourth minus 18x cubed plus 10x squared, just so that I have the exponents going in descending order. For 18 and 10, I'll have a factor of 2 in common, and I want that, since that first term is negative, I'm going to factor out a negative to make that first term positive. So we have negative 2, and then this one has 4 x's, this one has 3, this one has 2. They all have 2 factors of x. When I divide all 3 terms by negative 2x squared, I'm left with 2x squared plus, divided by 2 would be 9x, minus, because I divided by a negative, 5. Okay, we want to see if this trinomial is factorable. Our target product is going to be 2 times negative 5 or negative 10, and our target sum is going to be positive 9. So two numbers that multiply to negative 10 and add up to positive 9 will be negative 1 and positive 10. We're going to use these to expand the middle, replace that middle coefficient with negative 1x and 10x, because we know that that adds up to 9x, right? That was our target sum. So that gives us negative 2x squared, and then we have 2x squared minus 1x plus 10x minus 5. This allows us to factor by grouping because now we have 4 terms, and we're going to pull out the GCF from each grouping and see if we end up with something in common. This first grouping, I'm going to factor out an x, leaving behind 2x minus 1. The second grouping, 10 and 5, have a factor of 5 in common, leaving behind 2x minus 1. These two terms do in fact have a common factor of 2x minus 1. So we have negative 2x squared times 2x minus 1 times the leftovers, x plus 5. Putting this all together, the numerator over the denominator, we have 4x times 2x minus 1 times x plus 3 divided by negative 2x squared times 2x minus 1 times x plus 5. All right, let's start canceling. We've got 2x minus 1. We also have, look, 4 and 2. This would become a 2, and this would become a minus 1. And then we have one factor of x up here, and we have 2, so that's going to make that exponent go away. What do we still have left? We have 2 in the numerator and x plus 3 in the numerator. In the denominator, we're left with negative x times x plus 5. I would leave my answer like this. Talk to your instructor whether you need to distribute through, but I say again, less is more. Leave it like this. These have been examples of simplifying rational expressions. Thank you for stopping by.